Friends, good morning. Myself, Dr. M. A. Chennaya, and in today's video, we are going to learn about the projection of a circular lamina or a thin circular plate, which is lying on the line of intersection of VP and HP, and its surface is making some angle with HP. Friends, first of all, let us analyze the problem and then come to its solution. It is a circular lamina. The diameter is given to be 50 millimeter and it is lying on a point of its circumference on the line of intersection of VP and HP. So what is that line of intersection of VP and HP? Friends, it is nothing but the XY line. And remember, since the another point is on this line, both in the front view and in the top view, you are going to get the projection of that as suppose the point is A dash and A on the XY line. That is the proof to show that we are getting the correct solution for the problem. Friends, what I do in this problem, I keep the lamina on HP, obtain its top and front views. So in the top view, this lamina is seen as a circle of the given dia, and in the front view, you are going to get a line on XY, and the length of that line is equal to the diameter of the circle. And let us start with the top view, a circle of the given diameter. So I have drawn a circle here and divided that into four equal parts to start with. So this I will call it as 550, indicating the circle has got a diameter of 50 mm. And friends, now this circle has no corners or edges. It has got only a circular periphery. So to obtain the points, you will have to divide this periphery or the circumference of the circle into some number of equal parts. Generally, we divide that periphery into 8 equal parts. Friends, you have the circle now. I have divided that into 4 equal parts. And if I just draw a line at an angle of 45 degrees to the horizontal, you get 2 more points, and again from here another line perpendicular that will give you 8 number of parts. So let me label them as A, B, C, D, E, F, G and H. So this is how the periphery of the circle is divided into 8 number of equal parts. Then friends, let us obtain the corresponding front view on the XY. So I am going to draw projectors from all these, from A and E. So this is A dash, the last point is E dash, center you have got C and G, C dash, G dash. Here you get B and H coming on the same vertical line. I will call it as B dash and H dash. Similarly, G and F, D and F, they come together, they fall on the same line. I will call it as D dash, F dash. Friends, you have got all the 8 points on the periphery on the XY line. So friends, let me join all these and obtain the front view. So friends, I will just represent this distance as m, which is equal to 50 mm. That is the maximum length of this line. So friends, we have got the front view and the top view of the circle for the given dimension. Then what does he say? That the surface of this lamina is equally inclined to HP. What's the meaning of that? The surface is this line is inclined equally. That means it is making equal inclination with both HP and VP. That is, The angle of inclination of this with the HP is 45 and also with that of VP is 45. Since what I do now, I have this front view. I am going to redraw this front view here at an angle of 45 degrees to HP. That is theta equal to 45 and the length of that will be equal to 50 mm. So I take some point at random and draw a line here. A line of length equal to A dash E dash of length is equal to M, that is equal to 50 mm. So I will say M which is equal to 50. So I just obtain the front view and this angle is given to be 45 degrees because it is making equal inclination. This 45 degree I will mark later on because there is no space here. So on this line, locate all these BH, B dash, comma H dash, then comes C dash, comma G dash, exactly between A dash and E dash. This is D dash, comma F dash. So this is how the line or the surface is inclined to HP at an angle of, that is theta is equal to 45. So remember in this question, theta is equal to phi is equal to 45 because the surface is making equal inclination with both HP and VP. Friends, let us obtain the corresponding top view. What happens when the surface was on HP like this? We had a circle. When the surface is inclined to HP, so this length, the diameter perpendicular to the board remains same, whereas the lateral length gets shortened depending on the inclination. So friends, I will obtain these points one by one. So first I will get the end points, 4 end points of that, and then mark all other points one after the other. Friends, what are these points? Let us see. So I have drawn lines here. So let's get one by one. First, last extreme points. One is A, opposite to that E, A and E. Here is G, the opposite side point is C. So then we can obtain other points, namely D, F, H, B, etc. by projecting lines from here. So I'll write a horizontal line through this. So vertical line through this and get all other points. So 4 points you have got, 4 points on the periphery, 4 more you will get here. Just see, a vertical from B, horizontal from B, this will give you point B, C, at equal distance on the other end, this gap is equal to this, you will get the point A, B, C, D. E you have got F, and you have got G is going to be H. So friends, you have got all the 8 points. So this is A. So friends, join all these points so obtained in the box by a continuous smooth curve. And this is how you get the top view of the lamina when the surface is making an angle of 45 degrees with the HP. Friends, in the question, but here you can see here, the point is on HP on the XY, no doubt, but it has to rest on XY. So what is to be done? Whatever the top view we have got here, the top view of the circular lamina, that is an ellipse, I am going to redraw this figure here on XY such that the point A is on XY. How it is done? It is very simple. Friends, for all figures like circular lamina, semicircular lamina, pentagon, hexagon, for all such lamina, You will have to enclose that figure in a box. So friends, I am going to enclose this ellipse in a rectangular box like this. You can show by thin lines. So this figure, this construction is required to redraw or to recreate this figure such that A is on this. Friends, I will call this box as PQRS. PQ, this is R and this is S. So in this box PQRS, the rectangle, whatever you have got, we have enclosed the ellipse, the top view of the lamina when its surface is inclined to HP. So we are going to redraw this figure such that that line PQ which has got the point A which is on XY will come here. So friends, I am going to redraw that box here. Redraw that box such that this point A will come here. So PQ also will mark first. This is P, this is Q, this point is R, and this is S. So in this box, whatever you have got here is to be marked here. The points are there. So on PQ you have point A. PQ is here exactly in the center. You have got point A. Then opposite to that A, you have got E. Right, a vertical from there, you will get this point E. So you have got AE. Then exactly between P and S, between P and S, you have got G. P and S, mark the center point, you have got G. Then between Q and R, you have got C. Q and R, you have got C. So simply you can extend this line and get it. So four corners you have got A, G, E and C. Let us see how to get the other corners here. So friends, here you have got this point H closer to P. So we are going to draw these lines at the same distance. Whatever the distance of these points you have got, same thing is reproduced here. Friends, you have got these points here. A, this is going to be B here. A is here. This is B. This is C, D, E. This is F, and this is G. A, B, C, D, E, F, G. So you have got a point here. Friends, you got all the 8 points in this box. Join all these points so obtained by a continuous smooth curve without any break. Friends, this is how we get the top view of the ellipse. That is finally the top view. TV I will write down. Friends, corresponding to this top view, we have to obtain the front view. It is simple, friends. Get the points one by one. So I got A, horizontal line from A, vertical line from here. They meet at this point. I call it as point A dash. So A dash and A will coincide because the point is on XY. Similarly, friend, E will obtain E, the horizontal line from E, a vertical line from E. The point of intersection will give you E dash, A dash, E dash you have got. So on this I should get G and C exactly in the center. You are going to get G and C. So C is here, horizontal from C dash, vertical from here. They meet at this point. This is C dash. At equal distance on the other end, you will get G dash. So four corners you have got. Then I should get on these the other lines like this. D and F. D and F on that, and on this you will get the remaining points. Friends, here, so this is A, this is B. So vertical line, if you draw from here, on this you will get B. So this is point B dash, this is A dash, this is B dash, we got C dash, G dash, A, B, C, D, sorry, D, E, and F will come on this. So friends, you got 1 plus 2, 3, plus 2, 5, then this is 6, this is 7, and this is 8. Friends, you got 8 points for the front view. Join all these points by a smooth continuous curve. Friends, you got all the 8 points, and this is how the lamina looks in the front view when the surface is making equal inclination with both HP and VP. That is, theta is equal to phi is equal to 45 degrees. Friends, you can see there is something common between these two. It's only for the purpose of giving some important concept I am telling you. Since the surface is making equal inclination with HP and VP, the final front view and the top view, they are just identical in all respect. The front view dimension and the top view dimension will have same. They have the same diameter, same major axis, same minor axis. And friends, this is how we obtain the projections of the circular lamina when a point on its periphery is touching both HP and VP. Friends, I hope you are happy with the presentation, and if you are happy, please share this information with all your friends. Have a wonderful day.